Hi everyone. In today's video, I will try to show you how to use AnomaVision, which is anomaly detection system designed to detect the defects in your, let's see, structured data or any images. And someone will ask, what is the AnomaVision? It's let's see, AnomaVision is a production-ready anomaly detection framework. It's powered by the PADM algorithm. So also this optimized in top of the Ano detect repos or let's say implementation. And also it's designed by who understand the real world challenges. I have been working in an industry over 8 years and not just a theoretical but so into this video I will try to show you how to use this. And imagine you are able to detect the defect in production of any size, image size I mean, and also shape, color, and with minimal setup and also maximum accuracy. So you can see, for instance, the special features here is this smart memory. So you can I have trained this algorithm with 7,000 images, and also with a different image size and also image width. It's not needed to be a square image as the other implementations. So here you have the flexibility to use whatever you want. At the one constraint, it has to be divisible by 32 bit, 32, and also it supports several formats. Also visualization. You have to use I mean unified config. I will show you what does that mean. Also flexible image size, and also supports several formats like ONNX, TorchScript, or OpenVINO. And the next one is a TensorFlow. It's ongoing, so maybe in the next couple of days. I have no idea. And let's say just to show you what is the architecture overview of the pattern of the AnomaVision. It's a pattern indeed algorithm, which is just optimized. And how it's working, it's just extracting the features, building the Gaussian mixture model, and for the inference, we will extract also the features from the images, calculating the Mahalanobis distance, and then we have to detect, let's see, with this we will detect the defects. So how the training is working, we have to load the data. I will show you everything in a moment, and configure the system which is already configured. I mean the parameters, model training, and it will save the model training and also the parameters that have been used for the training itself. For the inference, you will try to load the model. I mean the config parameters that could be let's see that's saved by the after the training, or you could use another, let's see, config file, or maybe arguments. I will just show in a minute. And it's, let's see, optimized and with different, let's see, export model, let's see, formats. And for the evaluation, we have calculate metrics calculation, memory efficient mode. If sometimes you have a big, let's see, evaluation images. And I have also add an efficient memory function that you could be used for this stuff. And also benchmarking tool, I have also the compare between this one here, AnomaVision, and also Anomaly. Anomaly, it's also a GitHub repo, which is a well-known. It's let's see, maintenance by Intel. But I will show you also the comparison between my implementation and also Anomaly, and my implementation was outperformed the Anomaly. I will just show you in the real, let's see, test. And let's say just for the training, or maybe for the inference evaluation and export, it's the same. So you can use a command line interface. You can use just Python train, for instance, and add a data set, the parameter, the other arguments, or you can use the config file. Sometimes it's not, let's see, logic to add all of these parameters every time. So I have generated a config file that should be used instead of this argument, or it could be combined between command line let's see, arguments and also the config file. For instance, if you would like to add Python train and use the dataset, and you, let's see, change, you would like to use backbone, different backbone. So what you should do, Python, I will just show of course in a minute, Python, and also config should point to this file, and also let's see, a backbone should be wide resonant, and it will read this file, and for the backbone it will change it to the other one, the let's see, the wide resonant. And also for the inference, so after the training, the config file will be saved in a directory, and it could, you could use this without let's see, arguments like this. So there's any stuff here. I also compare between my stuff and also the Anomaly. I will show real test. And also, if you would like to use adding a new model, for instance, you would like to use TensorFlow. It's easy with 3 or 4 steps. Add the class here, for instance, you format, for instance, TensorFlow, and you need to create your backend like this. For instance, you have to add predict, close, and warm up function. The warm up, it's just to, it's mainly used for the GPUs. And also you need to add this in the factory, register in a factory. So your system here, it's not, let's say, interested in what model is loading. Just put the direct, let's say, the path to the home model if it's supported. I'm just assuming if it's supported, and it will do everything inside and give you the result. You don't care about which model I use, or change the code, or maybe like this. So after that, you can just use the wrapper. You can see here I have a wrapper, your model extend plus the extension, and device if you would like to use CPU, GPU, I don't know, maybe some other devices like Korea or something like this, and you can use this. So you see, after the integration, you have to use this. You don't need to mention that I have PyTorch, I have ONNX, I have I don't know, maybe some other formats. So, and it could be used for, yeah, this is the comparison between Anomaly, AnomaVision, and Anomaly, and you can see, for instance, the result of here, it's somehow close, but it's here you can see Anomaly with 003, and here the training time was 80 milliseconds, and you can see the anomaly 31 millisecond, and the inference time it's 32, and here is 11, which I have to study why it's doing this. This is the average, and also high, you can see the millisecond per image is 30, and here's 74. You can see here the AnomaVision, it's when, and you can see the export size, the model size is 15, and the anomaly is 40 megabyte. Here's the ONNX 31, and here's 40. The training time is 500. The training memory, it's 500, and here is 40 400. It depends indeed on the system itself, and you can see inference memory, it's 5, and here is 10, and big memory is, this one is very worse. So, and also this, I have run this on the environment of the anomaly, but if I run this in my environment, this will be 300 or 400. So I will just show you in a minute. So you can see the anomaly is 7 of 9 is, let's see, winning. And now let me just show you some practical stuff. Okay, so you have see this one here. Let's see, just move this, and here this is the main repo. It's another branch, but it's identical. Let's see here you have the train. You have here the export, you have here the evaluation, and here you have the detect. It's a detect, you can see it. Detect file, it's deleted or what? Yeah, see, it's deleted. And here, for instance, I would like to do the the training tree. So let's see what is the config file. The config file, it's somewhere here. Conf, yeah, config YAML file, and you can see here, add the path to your dataset. This is, for instance, only the path, the directory, and here you can see the class name. It's battle. The size resize, you have to use this one here, or maybe you can use even 212, 512. And if you would like to crop the image, if it's not, you can, it has to be, let's see, empty. Normalize, would you like to normalize it, so you can use norm main and standard diffusion, which is for the default for the ImageNet. And here's the model and training backend. It's either wide ResNet or a ResNet 18. Number of features, the final features that will be used for the training, it's 50, sorry. And the layers, so for each model here, for each architecture, we have 4 layers. And if you would like to extract the the features here, I'm just saying, I just would like to extract it from the first layer. The model will be saved in the distribution, and the model name will be model dot, I mean, this is the name of the model, and this is the output. Here's the batch size if you would like to increase it or not, and this is the device auto. It it will detect if you have a CUDA or not. So if you have a CUDA, I mean, for the training, it's needed to be a CUDA. For the log, you have the log info, and for instance, you can see what are the logs. This is, for instance, it's extracting the features, and here it's saving the model, and from this for normalize, I don't know. So this is, let's see, a log, which might be if you have a bugs, you can just stick it with the log file. And the visualization, would you like to have a visualization? I will say, for instance, yes or no. And this is, for instance, just fancy for the colors. And for the inference, you will have to add the path to image path to your directory. The threshold, it might be this one, let's see, fix, or you could detect this threshold automatically using eval. I will just show you in a minute. And number of focus is 1, and here pen 0. For the evaluation, we would like to use true or not. So for the export, export all of these, and this is the ONNX or offset, and this is just if you would like to use 32 bits, and maybe floating point 16, and etc. So this is, let's see, the config file. Now the training here, it will try to, if I run it just like this, Python train, it will try to load the model. Let's see here, load the config file. The config file, it should be in somewhere else. We have to identify this in this one here. You can see the default is config file, and the other parameters are none. Should be, let's see, none. Now imagine that you would like to use it. Let's see, batch size. This is the simplest one. So you can see, I can use also. So you can see, let's see, config config.yaml, and this should work. Let's see, it will try to run, and this config file, it will use this config here. You can see it's generating some logs. If you are interested in some logs, you can see the device is a CPU, CUDA is false, I have no GPU in my PC, in my notebook, and the back end successfully moved to CPU. Sometimes maybe you can just reduce the number of logs, but this was just to show me where are the errors. and you can see I have in the training 200 image, and the training was 28 seconds. I mean the training, it's not, let's see, important, but let's see here you have to use batch size is, let's see, 4, and you can see the batch size here is 2. Now this will be overwritten, the config file. So yeah, you can see here the image size, the batch size is now 4. You can just use it like this. And for the AnomaVision, it will save the stuff here. Yeah, sometimes you have, let's see, you would like to generate many, let's say, models, and this one could be controlled by with the parameters. Yeah, for the incremental path, I will just add another name. If you just see false, so it will, every time you train the model, it will try to generate a separated folders for this stuff. And this is, let's see, regarding the training. And if you see here, I have the training. This is the latest training. And here you have the config that's used in the training. It's just somehow copied, and plus the changes in the we have done in the training. Now let's see, this is the training, and I would like to export these models. So you can see export models. It's like if you have any config file, for instance, for the look, for the config as a parameter, now it's none. If it's none, it will try to use automatically the config one is saved on the model itself. And also for the model, it will try to also, sorry, you have to use the identify where the model is. Of course, you can add it by your let's see, Python detect, and also add these parameters, for instance, model data path, and add this and this, for instance. Now you can see we have no config file, so it will directly use the config that's already saved in the config file. It will use this one here. So now let's export. Oh, this is detect. I need export. Python export. So I will just use the default stuff. So now you can see it will extract the model, the models. Sometimes the ONNX generation, it saving the model, it will add, let's see, many warnings. So I have just stopped these and this using this stuff here, just to save, to see with the, if you have any error, it will show you what is the issue here. So you can see now the model size is 70 because I have different. Why it's 70 here? It should be indeed 30. This is the ONNX. I have several parameters, or maybe I just change the parameters to have different layers. Okay. Now let's see here. I have. Let me just make sure that if I have used some other stuff. Oh, it's 500. I was thinking why it's that. So let me just try to train it Python. Python train to just save it in a minute. So this is just to give you that the model can be trained on a different image size. It's not needed to be a square. Okay, almost done. So let me just now did the export. You can see here the training it took 18 millisecond. Now let's see export. It will overwrite these files here. So you can see for instance is okay, it's already received. So now let's see, this is the ONNX model is 30 or 31, and this is the TorchScript. Now, if you would like to use training, testing, let's see with the detect. For detect, you can use detect, and model, you can use PyTorch, you can use TorchScript, you can use ONNX, you can use OpenVINO, but this one it's still not still not supported. And let's see here, this could be also as a parameter here. You can see the image, the config file, it's none, so it will use the what is used in the training. The path, it's also image, it will use the config file here, this one here. And just you need to add the path, the model path. Let's see this one here. And you can see here, for instance, the default is PyTorch, and this is a dictionary. This is a dictionary stuff. This is I just saved the relevant information, that not just complete file. So if you see, the PyTorch itself is 76, and this one here is 15 megabytes, which is better for the, let's see, small devices. And now let's see this one here as none, and you just need for ops, for instance, Python detect, and you can see model. What was the model name here? Just, and now return it back. So for instance, I need PyTorch. So in the beginning, let me just show you something, which I will just with the visualization, just to show you the running time of each model. Let's see, false. What is that? False. Okay. Now let's be back. Just here, and let's see. I have to run this and to see what is the time of each for each image. Was it okay? I use two images for each script. You can see here for each two images, it's 100, 106, 118, 100. This let's just change it to 1. It will be better, right? Batch size. Also, you can add a T. Let's see, clear batch batch size is 1. Just to give you an indication of how the system is working. You can see the running time for each image. You can see here it's only one image, And this is here you can see the pure inference is 28 millisecond per image, and here's this average, and this is throughput. You can process 28 image per second, 28. So now let's clear this and use another one. Let's see, ONNX. And you can see the ONNX is if every model use here the CPU. You can see the CPU, and here you can see the throughput here 34 images per second. And let's now try maybe OpenVINO. Just add OpenVINO, just a directory, and it will directly load. So you just give this directory here and it will load all of these. And this is how to deal, let's see, with pattern, with AnomaVision. And you can see now for this 55 image. I also developed a C++ for the ONNX. I will show you flash next time. It's not, let's see, completed. And I wanted to see something. Yeah, for the evaluation, you can see just Python or Python eval. You can add the parameters for the eval if you would like to add, let's see, the data, where's the data, but it will be taken from this file here, from this. But if you want, you can just add through the parameters, and you can see, let's see, you can see, for instance, the battle here, and it's not required. This is done. Otherwise, it will read it from the uh, open config file. Here I'm just using the ONNX. You can use whatever you want. It's the same. I will show you the result, or let's see the visualization of each model. All models here are identical, so there is no difference between ONNX, PyTorch, OpenVINO. Every model have to give you the same result. So now I'm doing the evaluation, and you can see the image score map. The image level, I mean, under the curve, you can see this is the under the curve. This is for the image, and this is for the pixel itself. So you can see it's really high. And I just wanted to show you, yeah. So now let's change the config file. Not this one, but for the, I would like to save some results. Let's see. So you can see here, I have just comment these out. Enable visualization. Let's see, true. So you can say I can change multiple lines with one click. For instance, if you have any false here, you can just select this and Control D. It will select all these parameters, and you can just, for instance, change it one time. This will save several seconds. Let's see. Okay, so let's now, of course, the detect could be, this is the detect model OpenVINO. You can, let's do, okay, with OpenVINO. You can see, for instance, bash 3 size. Let's see how if should that work. Also, this supported with, let's see, intensive test. So if something is broken, you the test, it won't be, let's see, working. And let's just see this. I would like to kill this process. I mean, several images are enough. Okay, so let's see, call this one and dot ONNX, and I will just move to the result directory, which is visualization. Let's just compare the, still not, let's see this one here, just to compare only two images. This is for the ONNX and more, I mean OpenVINO. Now ONNX, so you can see both images are identical. So this is the OpenVINO and this is the ONNX. So this is, let's say, sometimes in OpenVINO, in Anomaly, you have different, let's see, result from what you have from model to model, and you have to take care of this. But here everything is identical, and I have also add the test to test every model here. And let's say I have these models, OpenVINO, Anomaly, I mean ONNX, and this should give you all the results are identical, otherwise it will be broken. So I have this, I have done this also for me. If I change something in any model, it has to give me a hint. Hey, have you have changed something here? I think that's it for today. If you have any question, just drop it down in the comment below. I will answer it definitely. But please try to give it a try to access the Anomalab, and give it, let's say, a star. If you have any question, just or let's say issue, I will definitely answer it. Thanks for watching and see you next time.